Hi guys, welcome back to my channel Engineering Chronicles of Plant Design, and in today's video we are going to see the nozzle sizing as per ASME Section 8 Division 1 for a pressure vessel. Nozzle neck thickness is determined as per UG44 and UG45. So we'll see there are some steps to be taken to determine the nozzle neck thickness. So you know what is what is nozzle neck thickness. Okay, for example, this is the shell. Okay, and here you have a nozzle, and this is the flange, okay. So thickness, let me change the color. So thickness of this particular nozzle neck has to be determined by this step. Okay, so by this step or by this UG4445 you will determine the nozzle neck thickness, which is particularly here. Okay, and in my previous video, if you go and see, we have also determined the flange rating, how to determine the flange rating based on the internal and external pressure. So there are some steps to be taken. We have to determine TB and TA, and in TB we have TB3, TB1, TB2, and maximum of TB, TA and TB is the required nozzle neck thickness. Okay, so what is TA? So TA is nothing but the thickness of the nozzle based on UG27 and UG28, and there has to be applicable loadings if there is a shear stress cause any loadings given. So based on that we have to determine TA. We have example in the next slides coming, where I'll be showing you how to determine TA, TB1, TB2, TB3, TB3, UG45 and nozzle neck thickness. So TB1 and TB2 is nothing but the shell thickness based on the internal pressure is TB1 and based on the external pressure is TB2. But this two thickness should not be less than UG16B. So UG16B states that for any pressure vessel, a thickness of the pressure vessel of a shell should not be less than 2.5 mm. For example, if your required shell thickness is 1.5 mm, so it should be round to 2.5 mm. Okay, and TB3. So TB3 is nothing but the thickness from the table UG45. So for example, your nozzle is 1 inch. So for example, nozzle is 1 inch. So your nozzle thickness must be not less than 2.96 mm. Okay, it should not be less than 2.96 mm. For one inch nozzle size, and in inches it is 0.116 inch thickness, and in mm it is 2.96 mm. Let's take an example. An example to determine the nozzle neck thickness, and for that let us take an example of nozzle size 50 mm on a shell. For example, this is the nozzle, this is the pressure vessel. Okay, for example, the pressure vessel, and you have nozzle here, so you want to determine the thickness of this particular nozzle. So how to determine that we are going to see. So this nozzle is of 50 mm. Internal design pressure is 1.2 megapascal, which is around 12 bar. Design temperature is 65 degrees centigrade. Corrosion allowance 3 mm. Joint efficiency 1. They have provided joint efficiency as 1. Sometimes it can be 0.85, 0.7 also, depending upon your what? Depending upon your radiography. Okay. Go to my previous video and see how to determine the joint efficiency as 1, 0.857 based on the radiography. Nozzle material is SA106 grade B, and vessel material SA516 grade 70, and determine the nozzle thickness. And shell diameter, internal diameter is 900 mm. Okay. So before the first step when we do a calculation is always determine the design properties of the material for 106 grade B and for 516 grade 70. So for shell SA516 grade 70, design temperature 65 degrees centigrade, allowable stress is 138 megapascal. For nozzle also and for flange also it is same 138 megapascal only. Okay, so this is the first step to determine the property, and for this you have to go to ASME section 2 part D, in where you will have to go to the particular table of this material of this two material, and as per temperature you have to determine the allowable stress value. Okay. So moving on to next step 2, which we will define the nomenclature with all the values, which is the internal design pressure is 1.2 megapascal, temperature as 65 degrees centigrade, nozzle diameter as 60.3 mm, and corrosion allowance is 3 mm, nozzle materials SA106 grade B, nozzle allowance stress allowable stress value is 118.0 megapascal, joint efficiency as 1, vessel allowable stress vessel allowable stress is for shell, okay, 138 megapascal also, and internal diameter of pressure vessel is 900 mm. So step 3. So you know how I find this 60.3 as a nozzle outer diameter. So for as per ASME 36.10, so for 2 inch, that is 50 NB or 50 DN or 50 NPS, the outer diameter is 60.3 mm. It is fixed. So always for a pipe, outer diameter will remain constant, inner diameter will change depending upon the thickness. So to determine TA, because we have the outer diameter now, so we have to follow mandatory appendix 1-1A, since the pipe is nozzle. Okay, and we have fixed outer diameter. So as per this mandatory appendix 1-1A, this is the formula. The formula is TA is equal to Pi into D0 by 2, which is R0, divided by Sn, this is allowable stress value of nozzle, into efficiency, into 0.4 Pi plus C. C is nothing but corrosion allowance. So from here TA we get the value as 3.31 mm. Okay. Now we determine TA. So next step is to determine TB. So for TB, so very first step is we have to find the nozzle, so the shell thickness, right? Correct. So shell thickness based on the internal pressure. So shell thickness as per UG 27C1, TB1 is equal to P di plus 2C divided by 2 SE into minus 0.6 P plus C. C is the corrosion allowance. So here, based on the calculation, we can find TB1 as equal to 6.96 mm. Okay, and we can have TB1 as 6.96 mm. So then TB2. TB2 is as per the external pressure. So we'll take a normal vessel here, since it is a not it doesn't have external pressure. So we'll consider TB2 as 0. So TB3. So TB3 we have to take from table UG 45. Correct. So as per UG 45, this table, as per this table, so for 2 inch you can find the thickness as 3.42 mm. So I have taken 3.42 plus corrosion allowance, which is 6.42 mm. So we have to find TB, final TB, from this formula. So final TB, which will be minimum of 6.42 and maximum of 6.9 and 0 because external pressure is not applicable. So TB will be minimum of 6.42 and 6.96. So here TB is equal to 6.42 mm. Correct. So we have found TB as 6.42 mm. So now final step is to determine the nozzle neck thickness based on what we have got TA and TB. So that is TUG, which is maximum of TA and TB. So TA we have got 3.31 mm as per the shell, the nozzle, which is mandatory appendix 1-1A, correct. And for the TB we got 6.42 mm. So maximum of these two. So we got TUG 45 as 6.42 mm. So calculation does not end here. So now why it does not end here? Because we have selected pipe as a nozzle, correct? So for pipe, there is always a fixed ratio of fixed thickness of every pipe which is available in the market. As per ASME section, as per ASME, that is 6.10. And since the pipe is manufactured or it is like rolled in a certain way, so there is a tolerance, manufacturing tolerance, which is taken considered into consideration of a thickness calculation, which is nothing but 12.5%. So the required thickness of a nozzle will be TUG45, which we receive from here multiplied by manufacturing tolerance. So manufacturing tolerance, how much? 12.5%, right? So TUG45 multiplied by 1.125, which is equal to 7.22 mm, is the required nozzle thickness. Okay, so required nozzle thickness is nothing but 7.22 mm. is 7.22 mm. So we have to go to a table of ASME 36.10, and from here I have selected schedule 160, schedule 160 for the nozzle, which has 8.74 mm, which is greater than 7.22 mm. So set it nozzle is schedule 160, and the funnel nozzle thickness is how much? 8.74 mm. So this is how you do the nozzle neck thickness, and I hope you have liked this video. So please share, subscribe to my channel, and like the video. Share it to as much person as required, because there are so many person who want to know about the static pressure vessel design or static vessel design, static equipment design. This basics which I am sharing with you is will be very helpful for them and for you also. Thank you. Thanks a lot.